Hello and welcome to this lecture on integral calculus. In this video, we are going to see about triple integral in Cartesian coordinates. So, first of all, we shall see how the general form in triple integral. So, already we have seen double integral problems. We have solved so many. There, it will consist of two variable. Here, it will be of three variables. So, we have to integrate the given function with respect to three variables x, y, z. It can also be in other form. Either it will be of dx, dy, dz or dz, dy, dx. So the limit of x will be x1, x2. Here it is in the general way, and dz will be of z2. So this is the inner integral. After evaluating this, we will go for y. At last, we will integrate the resultant function with respect to x, same as the double integral problem. Now we go for the problem. The first problem, they asked to evaluate this triple integral. The given function is x, y, z. So, same as the double integral, first we want to evaluate the inner integral part. So, here we want to integrate with respect to z. So, the remaining x and y will remain constant. In that case, x, y will be a constant. We may keep z alone and dy dx. If I integrate this, it will be of z squared by 2 and 0 to 3 and dy dx. Here xy will be there 1, 2. So while substituting the limit, we will get 9 by 2 and 0 xy dy dx. Okay, so we are splitting out the inner integral part alone. So at last we get xy 9 by 2. So for our convenient, I am taking the inner integral alone first. Now we find the value xy 9 by 2. Next, we will substitute to the given function instead of this inner integral. Then we will go for the evaluation with respect to y. So now I have substituted the value. I am going to integrate with respect to y. So simply with respect to y, 9 by 2 is simply a constant. X will remain a constant. So this is a constant, and we will integrate y dy. It will be of y square by 2. So while substituting the limit, we will get the value as 4 by 2. While getting cancelled, it will be of 2. At last, here it will be 9x. So now we have completed with respect to y. So we move for the last one with respect to x. So I will substitute the function 9x. So this is the outer integral. So if here 9 will be a constant, 0 to 1 x dx, it can be written like this, and while integrating this, I will get x square by 2. So 9 by 2 will be the final answer. Okay, I hope you understand this problem. We do one more problem. Here I have changed the order dx, dy, dz. So the same thing. So e power a plus b can be written as e power a into e power b. As same procedure, we can split this functions e power x into e power y into e power z. First of all, I am going to integrate this function with respect to x alone. So I need the e power x alone. So the remaining I may keep as a constant. So first I am taking the inner integral alone. This is our inner integral. So I am keeping that e power y plus z as a constant, and I am separating the function e power x. So while integrating e power x, again I will get the value as e power x. So e power y plus z will be a constant and the e power x and 0 to 1. So the final answer will be e power 1 minus e power 0. E power 0 will be always 1. So y plus z e minus 1. So this will be the answer. So now we have evaluated the inner integral with respect to x. Now we are going for the next integral with respect to y. So we will substitute this function instead of that and we will evaluate with respect to y. So we have substituted. Now we are going to evaluate with respect to y. See, e is a constant value and 1 is also a constant value. So therefore, we may keep that e minus 1 as a constant outside the integral. So 0 to 1. And here we need only a term of y. Other than y, everything will be a constant. So I may keep e power z outside e power y. Then dy at last dz. This is what evaluation we are going to do. So I am taking out the second integral alone for our simplicity. So here I am keeping the value as e power minus 1 as a constant and e power z separately. Again, integral e power y dy will be e power y again. The limits are 0 to 1. So I am substituting the limits as 0 to 1. So I will get the same value e power 1, e power 0. You will get e minus 1 and the remaining terms. E minus 1 already is there. I have evaluated this value alone. We get the value e power minus 1. So finally, for this integral, I may get the answer e minus 1 whole square e power z. This will be the answer. So now we are going to integrate with respect to z. So in this case, I am substituting over the second integral with respect to z. So e minus 1 whole square will be a constant and 0 to 1 e power z dz. Again, I will get the value as e power minus e power 1 minus 1. So e minus 1 whole cube will be the final solution. So I'm getting that e minus 1 whole cube. So with this, the second problem is over. And I have given few exercise problems similar to that what I have evaluated previously. So we can try these problems.